Hi, hello everyone. So today we'll talk briefly, very briefly about Firebase. It's a vast topic in itself, but we'll kind of just scratch the surface long enough, deep enough to give you a feel of how you can build an app that can interact with a cloud database, specifically through Firebase, and that will be helpful for your assignment as well. Okay. All right. So as usual, there is a list of recommended readings, all from the Firebase, Google Firebase documentation. Uh, they're pretty good guides, like you have seen with Android. Of course, with the continuous updates that we see, but largely simple, straightforward, understandable, and quickly implementable. Okay. Okay, so what is Firebase? It's a Google product, like several other products. It's a cloud-based product, as I said. And the idea is it's a developer tool that helps you develop, manage, and grow your apps. So the entire server side is handled by Google. It's part of their Google Cloud apps that share some resources from that. And it has its own certain specific applications or features. So no code or maintenance is required on the server side, not for hosting, not for scaling, not for any regular issues that you have to do for a standalone server usually. And it can connect a variety of clients and apps easily to a Firebase project. So the same server app can serve, for example, iOS, Android, and web apps. So this is great for creating cross-platform apps or apps that naturally have a lot of client and um, apps or devices. For example, emails or chat services or social media or games and so on. Yeah. It also has pretty good pricing options. So it's pay as you go, so pay as you use rather. So you pay only for what you're using and not for the entire infrastructure that you have to set up. So for your own servers, you have a lot of upfront costs just to get the thing set up and running. Here, that is not the case. The infrastructure is there for you, and you only pay for what you're using. They have two pricing plans. The first one is called Spark, which is the starter plan, and it's free until certain number of requests to the server, and it is good enough for student projects like ours. And then there is Blaze, which you have to upgrade to and pay if you are making or if you are taking your app public to the market. Okay. Yeah, however, be careful. It has a limit on number of projects. And once you delete a project, it still takes about 30 days for it to be actually deleted. So, don't just create a bunch of projects and delete and then create a new one. Be careful with that. You should have room for a project to do the assignment at least. It's one of the more immediate concerns, I suppose. Okay, you can manage everything for that Firebase server side through the console, that is console.firebase.google.com. Okay, so let's get started. If you click on that link, this is what you'll see. Something like this. So I already have a tic-tac-toe server, and Friendly Eats is the tutorial app that Google people have provided. So I have those, but you'll probably have this blank, and then you'll see this add project button. If you click on that, you'll see a wizard like this. In the first step, it asks you for a name of the project. And as you start typing the name, it starts capturing this unique project name based on that. Okay, so usually you don't have to edit it, but if you are picky, if you want a specific name, you can go ahead and make changes. Just be careful, once you have created the project, you don't get to change this. You can change the project name, but not this project ID. Okay, and here I'm seeing a warning because I only have 3 projects remaining. I have few in that delete queue. So once again, just be careful. Okay. From this point, just follow the prompts, keep the default options, that should be okay. And wait for it to create the project on the cloud. It takes some time. So wait patiently. Once that is done, you'll see something like this. Okay. So yeah, in this video, we are going to see a toy library app in which we just add our books and then get some information about the books on the other end. All right. So you'll see this interface, and click on the iOS, Android, etc. to create or add an app on the other end. So we are interested in Android, and this is what you should do to add an Android app to your Firebase project. Okay, first step, create an Android project that meets the prerequisites given here, at least KitKat API level, at least Android 4.4 higher, Jetpack, that is Android X, and yeah, and Gradle version 3.1 or later. Now it's 7 plus, so use that, and compile SDK version 28 or later. So and most of these will be fulfilled anyway. And yeah, of course, have the latest Android Studio, nothing difficult at all. So once you have that, then grab your package name, and you'll use it again on the console like this. So on the console, next step, you'll have to register your app using the package name. So here I have put Android samples.java.library and then give the name of the project. I have left the SHA-1 entry here blank, but you should use it for authentication. Otherwise, anyone who is using this package name can use your app's data, and then if you go beyond the free limit, you'll be billed. Okay. So yeah, register the app, and then you'll see this prompt where it creates a Google-services.json file for each project with the appropriate links and data and authentication, etc. Download it and put it inside your app folder inside your project, and that's it. That's the configuration. Like for connecting, from on the console side. On the client side, you have to make a few more changes. So first of all, in the top level Gradle file, you have to add this class path, com Google GMS, Google Services, and the latest version. Okay. Then so then before going to our app level Gradle file, we will talk a little bit about the kind of database we want to use. So Firebase supports a couple of different types of databases. In this example, and also for the assignment, the real-time database is sufficient. So what's that Firebase real-time database? It's basically a NoSQL database that stores and syncs your data across all the devices. Across all the clients that you want to provide in future. It also handles network breaks. So you don't have to do anything special for that syncing. You don't have to do anything special beyond a little bit of configuration for the project being capable of handling offline caching of your data when disconnected. Okay, I'm not showing that part in this example, but it's easy to pick up from the documentation. So I leave it as an exercise if you're interested. This database is stored as a JSON tree. I hope you're familiar with JSON. It's a lightweight, portable, hierarchical database, a bunch of key value pairs. It has a danger of creating very deep hierarchies. So avoid that as a best practice, because then you end up digging deeper and deeper to just get the basic information out of it. But yeah, so each JSON key will become a path, and you can read right from that path in your client code. And we'll see a bunch of examples soon. Okay. So yes, we will make changes to the app level Gradle file that include real-time database as well. So this is what the app level Gradle looks like. And you'll add this, the plugin for Google GMS, Google Services, and also this implementation dependency for Google Firebase database. Again, make sure you use the latest versions. Okay. These steps can also be completed via the Firebase tool or Firebase assistant in the Android Studio. So go to tools and then Firebase, and then it will guide you through those steps. But you can directly do this. It's nothing special. The tool basically writes the Gradle files only. All right, yeah. Once you have done that, go back to the console, and this is what you'll see. You'll see the library project is added as an Android project to this app, and it still gives you the option to add other apps. So you can have an iOS client side or a web app as a client side or whatever you want. By the way, make sure any client projects you add are similar in nature, like they are going to use the data in a similar way, so that there is consistency, there is similar expectation and similar user experience. Okay, all right. After that, click the Realtime Database tab in the left column, and then go ahead and create the database. Now, when you're creating the database, that is where you're actually creating the placeholder for the database. There are two things. There is a locked mode, which is secure, and there is a test mode, which, as the name suggests, is for trying things out. So for now, we are going to keep it in the test mode, but it has very low security, and all the data will vanish after 30 days. So make sure you use it only for the appropriate purpose, and then switch to the locked mode at the right time. So yeah, let me highlight it again. It's only for testing. It's not recommended for the production code. Yeah, but apart from certain changes to the rules, the developer experience and of course the user experience is going to be the same. So we stay with this for now. Yeah, so when you go through all the steps and create it, this is how the empty database will look like. You see the database URL, and its value is null for now. So unless you add something, there is nothing in it. Now, let's go ahead and add something. Let's do a quick sanity check. Okay. So first of all, modify the UI of your app to look like this. Basically, instead of the hello world text view, we have a button which, when clicked, will push the message hello world to the Firebase app. Okay. What we need to do is get an instance of the database and push the message on that. So this is the change in the main activities code that you will make. Grab the button with its ID, then set it on click listener so that it finds the database's instance and then captures its reference with the path message or the key message. Now, since these are NoSQL databases and these are JSON trees, if you provide a path which does not exist, it's going to create that path for you. So we grab that, call it myref, and then set value hello world. So the moment you build and run this code and then push the button, this is what will happen on the server side. You'll see a new entry whose key is message or the path is message and the value is hello world. Okay. So this gives us confidence that our things are working, everything is wired correctly, and we have done that sanity check. Now let's go ahead and create our libraries book database. Okay. So before that, let's update the UI further, make it look like this. There are two edit text, one for the title, another for the author. And then the buttons, that button's text is changed to add book. So we'll just add the books to the database. And there is also a text view below the button. You can't see it right now because it's displaying an empty string. Okay. We'll use it to update this, like show the status of certain things we do. Then create this new Java class in your source. You can, of course, name it anything. I have named it book info. It has two private string fields, title and author. This @ignore extra properties comes from Firebase, and you'll see what thing you need to import in the code, or you can also do that auto fix, and it will add the appropriate import statement for you. Now, the fields can be private, but if they are private, they must have public getters, or they can be public. Okay, so we'll keep them private and use the getter. So these are supposed to be properties like in Kotlin, and for compatibility with Java, this is the trick you have to do. So don't forget to do that. Okay, then we are creating this. We also need that empty constructor for certain things that are again related to Firebase. So, although it doesn't do anything, although your Android Studio may throw warnings, these two things you will have to do in your code. Okay? Otherwise, you'll end up seeing error messages that are pretty cryptic. Anyway, I have also added toString, not compulsory, but I prefer to add toString to classes, so I can use them in log and debug messages, so I can see what's happening. Which of my objects are touched or modified or whatever. Anyway, some of you may remember the entities we created in room databases. Yes, these look pretty similar from like the developer's end. Of course, the difference is the room database uses SQL underneath. This is a NoSQL database, but of course, client code sees very little difference. So that's another interesting advantage. All right, now let's look at the client code on how to insert a book value in the database now. So some changes to the main activities on create. We grab the book ref, a new reference with the path books now. Earlier we did messages, now we want to do books, which will hold a list of books as we add, right? You're grabbing the button, then setting the on-click listener, and that click listener grabs the title from the appropriate edit text, grabs the author from the other edit text box, and creates a book info object using that information. Okay. And then we put this book info object onto the bookrefs path in Firebase. But you'll spot a small difference here. We are doing bookrefs.push.setValue instead of bookref.setValue before. So push reference, which you get by calling .push on the reference object, is recommended for creating list data. Okay, so here we want to add a bunch of books, so we want to use list. The biggest advantage of this is it creates a unique key when it is adding this book info or any object that you want. And while doing it, it creates the key based on the timestamp, and it's unique, and it's also ordered chronologically. So the advantage here is even if you have multiple clients trying to add new data at the same time, they will not conflict with each other. If we were using, say, the book title as the key, and then if two of our instances try to add the same book title at the same time, there could be conflicts and then unexpected behavior. So this is the recommended way of adding lists, and make sure you use those if you're using lists. Okay. Next, let's see an example. So here I ran it on my device, and I added Harry Potter and Prisoner of Azkaban, one of the Harry Potter books I like the most, and the author is J.K. Rowling, and then I click add book. So when I do that, as I said, the ID or the key is created by Firebase, and it shows this on our server side. So you see the path books, then the key, is a sort of a human readable version of a unique key. It's a string, so yeah, that way it's human readable, but garbled string. And then it has author name, title name as its children. So books now has a child whose key is minus MOWO blah blah blah. Okay. And that is created for you free of cost. You don't have to do anything. You don't have to worry about those conflicts or push or anything like that. Okay. So very simple, couple of lines of code can give you the ability to create database entries like this. Next, let's see how we can read the data from the database. Okay. All right, so yeah, here is a code, but let me explain a couple of things before that. So Firebase allows you to add two different kinds of listeners to your references, database references. Here we are looking at a child event listener, which is the recommended one for list data. The other type is value listeners, which you can use for the non-list data, like the hello message that we had, for example. Why use child event listener? Well, as you can see in the callbacks, let's quickly go over those. The first callback it adds is on child added, then you have on child changed, then you have on child removed, on child moved to some other path, and on cancelled. So all of these, they pertain to some modifications to the child. That's why the name child event listener. Now, if your list data is large, which is the intention, you want to create scalable cloud-based products with this, you don't want to have a listener that will look at the entire thing and slow down the process if you want to have listeners like that. Here, you have listeners that give you a specific data, the added child or the changed child, and then you can only deal with it when it's updated. Okay, so that is the idea. And make sure you use child event listeners when appropriate. Okay, let's see what we are doing here. The on child added gets a parameter called data snapshot, which is the entry that triggered this callback. That is the entry that was added, child that was added. The second parameter is the previous child's name, and that will be the name that was just before this one in the list. Okay, so that's a good marker or a cursor for us to use. Let's see, what are we doing here? We get the value as a book info object here. Snapshot that get value and then pass the class. So it casts it and send it to the book info object. And then we grab the text from it by doing added book info.toString if it's not null. This is just a guard, so in case we get a null value, it should not crash. And then put it on the text view, whatever you found. All the other callbacks are not implemented right now, just in this example. You may want to use it in your project though. Okay, finally, attach this listener to the reference at the appropriate path. Since our books ref is the books path, that is the right path. Otherwise, you may want to go to, you want to do books ref dot child blah 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 and get the appropriate one. Okay, let's see the effect of this. So yeah, here is the screenshot after we added the first book, and we see the title, author, and this. And then let's add a new book here, another recent favorites of mine, Suhail Dev by Amish. And when you add the book, what will happen? When you add it, you'll see the new book is Suhail Dev by Amish. That's the entry you get. And also on the server, you see Suhail Dev and Amish in the same tree as a second child under books, the child after the Harry Potter book. Okay, so yeah, that's how you can read and write the data at the same time. And another thing I'd like to highlight here. So the first, the leftmost screenshot is from my emulated device. The second one is from a handheld device. And the third one is again on the emulated device. So what I'm trying to show here is, although I added the book on my handheld device, the change was reflected on the emulated device at the same time. The real-time database is magic. Okay, so you don't have to do anything special to push it to the other client. As long as you have the proper connections, you'll see the changes on the other side instantly. Okay, so that's all for Firebase. And but yeah, you'll have to dig a lot deeper in the documentation to make a meaningful project. Okay, so all right, we'll stop here. Wish you all the best. Goodbye.